All right, ready? All right, so welcome. My name is Nathaniel Moore. I'm a teacher over at Morton East, and this was our first assignment was trying to come up and explain this question about if ordering chicken nuggets in various box sizes. In this case, we have box sizes of 6, 9, and 20. Just like if you went to McDonald's or Burger King, if you try to order your chicken nuggets, you can usually get them in 6, 9, or 20. Now, let's say you wanted a very, very specific number. Like for instance, let's say you wanted 15. Well, there is no 15 box right there. There's no box of exactly 15. So you'd have to think outside the box, no pun intended, by ordering something different. Like 6 plus 9 would give us 15. Now that's in the case of that you want the exact 15 and 20 is too much, but 15 would be great. Now let's say you wanted more than that. Let's say you wanted exactly 26. Well, then we'd have to take 20 and 6 together to get that exact amount that you wanted, because maybe ordering 2 boxes of 20 would give us 40, and that's too many nuggets. So the question was, what possible quantities could we order with these boxes of 6, 9, and 20? Which ones would we be able to get? The other question is, what quantities could we not possibly order, given that the chicken nuggets come specifically in these numbers? So the first thing that I tried to do here was set up this idea about ordering boxes of nuggets. Now, what I did is that I cut up some of these to represent 6 nuggets. So anything in red like this and these candy stripe ones will essentially be a box of 6 nuggets. So obviously, if I order 1 box, I can get 6. If I order 2 boxes, I would get 12. 3 boxes would give me 18, then 24, and essentially at this point, we're just going up by 6 each time, ordering a box of chicken nuggets. So if we keep going on here, we'll obviously get all the multiples of 6, 12, 18, 24, 30, 36, etc., etc. Now, on the right side is if we wanted to order boxes of 9. So I have those in green. So here we go. 9, a box of 9 with another box of 9 would give us 18 chicken nuggets. If I get 3 boxes of chicken nuggets, that would be about 27. And if I order 4 of them, I would get 36. Now, if you start to notice, anytime we order 2 or 3 boxes of the red or the 6-piece and 2 boxes of the 9-piece, we get the same quantity. Same thing here. If we order 3 more boxes, 24, 30, 36, along with 2 more boxes of 9-piece, we also get 36. And this will happen a third time as well, and it'll keep kind of going like that. This is a more complicated term known as modular, and we won't be going into that today, but essentially we'd still keep climbing up this ladder like that. Now, there was a third quantity. The third quantity is right here, which was 20s. Obviously, in black is my box of 20 chicken nuggets, right? That takes up obviously way more space than anything else. So for instance, if I tried to line these up, they wouldn't quite fit on here because 3 boxes would be about 18. And if you notice, they don't quite match up and cover up all that 20-piece chicken nuggets, right? They're just a little bit short. So if we start adding these together, obviously a 20-piece and another 20-piece and another 20-piece would be 60 chicken nuggets. And if we push these back up here, we'd also get about 60 chicken nuggets, even if we lay these out. So now, seeing this had me ask the question, now, what numbers could we obtain and what numbers can we not obtain by adding these boxes together? Well, first, I decided to make a list of different numbers. Like for instance, if you added up all the 6 nuggets, 9 nuggets, and 20 nuggets. Well, if we add up all the 6 nuggets, here are all the different quantities we can get from obviously 1 to 100 if you want all those chicken nuggets. So these are the multiples of 6. Now, if we start with 9 nugget boxes, here are all the different combinations with 9 that we can get of different quantities. Last one is 20. We can only get about 5 different quantities with 20s. So here are all the different possible things we can get just by going with 6s, just with 9s, just with 20s. Now, here's where things get more interesting. What if we decided to order a 6-piece and then start adding 20s together. Well, now we're going to get some numbers that aren't here. For instance, if I have 6 and I add another 20, I would get 26, a number not obtainable beforehand because it would fall between these two. 26 is also not in our 9 pieces, and it's also not here. Or if I try to do something like this where I add in a 9 piece with a 20 piece, that'd be a 29, which also does not is not here, is not on this number, and is obviously not on this number. So then the other question is, what if we add all three together? 20 plus 9 plus 3. Well, 20 plus 9 plus 6 will give us 35, which is another number that we don't have access to yet. So these are new quantities every time. Now, moving forward, I made a list of different things if we start with 6 or if we start with 9. Now, let's say we start with 6 chicken nuggets like this, right? And then we just started adding 9 pieces. Well, 6 plus 9 would be 15. We add another 9. That would be 6, 24. So, and that would be a number we've already obtained. But what the whole point of this was to try to gain different quantities and different numbers. Or if we started with a 9 and started adding 6s, would we get different quantities as well? So I went ahead and did that. So if we started with 6 chicken nuggets, we just started adding 9s, we're starting to get new values, a different track or in different amounts of values. Now, these orange dots are ones that were already previously obtained by using our normal multiples of 6, multiples of 9, and multiples of 20. So if you notice, we have some new numbers here. Now, if we start with 6 and add 20, well, we start with 6, we add 20 plus 20 plus 20 plus 20, we get one more new value as well. On the other side, so continuing on, like if we start with 9, we'll get some new values as well. So 9, if we started adding 6s, we get some new values as well. Yes. All right. And then starting with 9, if we start adding these together, we'll also get some values like this as well. So nothing new that we already haven't obtained before here. Actually, I think all those are new. Yes, all those are new, actually. Anyways, or sorry, like these are all new values, nothing that we've obtained before. Now, here's where things get even crazier. What happens if we start with 20? Well, obviously, if we start with 20 and added 6, we get some of these new values. If we started with 20 and added 9, we get these values, most of which are ones that are brand new, ones we haven't obtained before, other than 29. If we now combine all three together, like for instance, if we take 20 and 6 and then started adding 9, 20 and 6 together, we give us 26, we add 9, we start to get more values, none of which have been repeated yet. And same thing is if we started with 29, a combination of 20 and 9, and start adding 6. Once again, there are no recurring values that we've had before. Everything is new value. So to make it even crazier is that if we start with 40, adding 2 together, and we still get more and more new values, actually able to attain that 100 again. So in a different way. So the last bit of this was I constructed this sheet here of all the different values and different numbers we can obtain. For instance, multiples of 6 are in red. So obviously 6, 12, 18, 24, 30, 36, etc. are all going to be in red. Multiples of 9 are in green. 9, 18, 27. The crossovers of 9 and 6 are obviously in red to kind of show that as well. Multiples of 20 are in black. 20, 40, 60. I stopped at 60 just because I wanted to give an easier map of everything. Now, the most interesting ones are the combinations of 6, 9, or 20. If you start to notice, at the beginning, we don't really have many combinations. The first one being 21, whereas if we add 6 plus 9, we can get 21. And then we start to get more of them as we go further. And if you notice, this last row is nothing but combinations of 6, 9, and 20 in different degrees. Now, the purple ones are prime numbers. Those are obviously unobtainable by any numbers. That's their definition, meaning that they can only be divisible by themselves and the number 1. So everything in purple is a prime number that can't be obtained no matter what. Now the blue ones are unobtainable numbers to our values. Now obviously if our minimum value is 6, we can't get 1, 2, 3, 4, or 5. The next smallest number would be 9, and there's no combination of 6 and 9 that could give us 7, 8, 10, or 11. Now everything also between 18 and 12, because we're going up by 6, is lost as well. But as we go further and further, we can start to use different combinations to find more and more values. And so I hope that gave some people some number sense, and yeah.